Hello everybody, a very good afternoon. Good afternoon. I hope I'm audible and visible. Anybody there? Knock knock. All right, finally. Okay, great. Good to see Shlok is here, Hitesh is here, Pratham is there. Okay, great. Clearly audible? Great. Ramakrishna is here. Happy New Year, guys. Wish you a very happy New Year. How are you doing? कैसा है preparation? How are you feeling? कैसा महसूस कर रहे हो about the examination? Let's just interact for 5 minutes and then let's start with our agenda. We've always been rushing for our agenda. Let's give it some mellow start for the new year. And let's see what do you have to say. How are you guys doing? कैसा चल रहा है preparation? मुझसे अगर कुछ जानना है, that also you can tell me. Let's see. क्या resolution बनाए हैं? What are your New Year resolutions? Ma'am, I'm starting full syllabus tests from tomorrow. Pratham, good to hear that. Very important. Tests are a must. Okay? No matter how much you prepare, if you're not giving mock tests, you will never get an feel of how the examination would be conducted. सिर्फ knowledge grab करने से कुछ नहीं होगा. Knowledge को execute करना पड़ेगा. That's very important. Very good prep. चलो, great. Good to hear that, Shlok. आज का हमारा एजेंडा है प्रीवियस ईयर क्वेश्चंस along with the chapter. Okay, Shlok is asking me कुछ अजीब tables हैं like amino acids वाली, वो memorize करना है क्या? So, Shlok, let me tell you, बहुत smartly memorize करना होता है. There are certain amino acids which are essential amino acids. Do you have to remember their names? Yes. Do you have to remember their structures? No. Are questions being asked from the structures? Yes. But you would see those structures are not going to be very common structures. नज़र ज़रूर मारनी है structures पे. ये ज़रूरी है क्वेश्चंस आ रहे हैं कुछ ऐसे जो कि क्रैमिंग बेस्ड होते हैं बिकॉज एग्जामिनर वांट्स टू चेक ऑल योर स्किल्स बीट द लॉजिकल स्किल और द मेमोराइजिंग स्किल राइट. बहुत अच्छा है. मैथ्स एंड केमिस्ट्री इज ऑल्सो गेटिंग देयर. चलो प्रथम, आई होप प्रथम आएंगे आप. हिमांशु पांडे के एडवांस क्वेश्चंस कुछ बनाने लगे हैं. ओके ग्रेट. बट अगर जेई मेंस निकाल रहे हो तो अभी बस क्योंकि जनवरी स्टार्ट हो गया है, एडवांस क्वेश्चंस को एक लिमिटेड टाइम देना और जेई मेंस, क्योंकि मेंस नहीं निकलेगा तो एडवांस का कोई फायदा नहीं है. मेंस को फोकस ज्यादा देना स्टार्ट कर दो नाउ, राइट. चलो, डेली प्रैक्टिस ऑफ ऑर्गेनिक इज वेरी इंपॉर्टेंट. लाइक अजय प्रताप इज सेइंग, ऑर्गेनिक केमिस्ट्री इज वोलेटाइल एंड आपको पता है वोलेटाइल को कम करने का बिहेवियर एक ही है कि जितना प्रैक्टिस करोगे, वोलेटाइल नेचर ऑफ ऑर्गेनिक केमिस्ट्री एंड वोलेटाइल नेचर ऑफ केमिस्ट्री बाय इटसेल्फ रिड्यूसेस. ठीक है. बाकी आई होप हाउ द जर्नी इज गोइंग ग्रेट. Tree plant. You're a tree as well as a plant. And we know the difference. So do not worry about the language because chemistry requires no language any which ways I keep saying. है ना? So don't worry about the language. And with this, let me also say that it is important for you to clear your examination. That's there. That's certainly there. Nobody is denying that. But in the journey, do not become so overwhelmed that it starts taking this over. It starts taking your health over, your mental health over. So always maintain a healthy balance between your lifestyle and the learning. Never do it under pressure. Enjoy this phase because this is making you strengthened for the rest of your life, which is waiting for you. When you will pass 15 years, you would see that the preparation that you're doing here will help you in overcoming any kind of politics in the corporate setup or any type of family politics or any type of tasks which are given to you, and you would see others are panicking, but you are taking it at ease because of this particular phase that you're going through. So this phase is preparing you for a bigger goal. The goal is, yes, to clear the examination, but a bigger goal is to become even more persistent to the environment and grow as a human being. So I wish you all the best. I always keep saying your present you should be better than your past you. So let this be your target in terms of anything, in terms of your demeanor, in terms of your nature, in terms of your learning skills, in terms of acquiring new skills. So always be in a flow. Be in a flow. And when I say be in a flow, let's say you're learning a new skill or learning a new named reaction. You're not going to stop there. The next day, you have to learn something else so that you be in a flow. So with this, let's welcome 2024 with all the warmth. And I hope this year becomes the most memorable year for you and you achieve what you desire. So with this, let's get started. You know what to do, right? If you're liking the sessions, if you are enjoying the sessions, if it is giving you even some understanding, then please make sure you share it with your friends so that we reach more and more students. And you are the people we can only rely on, right? Because we know that you have tasted the flavor of good content. And this is a request to all of you that if you're liking it, do let your friends know about it, right? We're putting in a lot of effort to make sure that we make a change. We make a change when it comes to learning. And it's only with your help that we can do that, right? Okay, so with that, I hope you have also experienced the app and you're already on the Telegram channel. Those of you who are new to the channel, I hope you have also joined the Telegram channel and you've also tried the app, which is free for 15 days. And if you like it, go ahead. If you don't, just uninstall. As simple as that. Now let's begin with what we have to do. ठीक है? So चलें, कहानी शुरू करें. So Ajay Pratap is saying like we can do MS Chauhan right now or practice questions PYQs. So अभी जैसे कि मैंने कहा कि अभी अगर आप JEE मेंस देने वाले हैं जनवरी में, so अब जितनी भी एक्सटर्नल बुक्स हैं उनके लिए आप फुल स्टॉप लगा दीजिए, राइट? अभी मॉक टेस्ट का समय है, रिविजन का समय है, नए क्वेश्चंस उठाने का समय नहीं है. MS Chauhan is a very extensive book when it comes to the questions, and there are a number of questions, and not just that, there are variety of questions. So you might get lost in the jungle of the questions, which we do not want, right? So make sure you attempt the questions which are previous year questions. There's so many questions available because there's so many shifts of JEE mains, right? So good for us. Huge number of JEE mains question. Restrict to that, right? Restrict to that. That's smartness. What not to do is smartness. What to do, everybody knows what to do. What not to do is smartness, which will help you ace this examination. तो बच्चा पार्टी अभी तक हम कर क्या चुके हैं? अभी तक हम कर चुके हैं SN1, SN2, SNI mechanism. So we have done some substitution mechanisms. though the name of the different two sessions that I've conducted is not under the name of reaction mechanisms, I have given it a name of haloalkane and haloarenes only. So haloalkane and haloarene का part 1 हम कर चुके हैं. The part 1 contains actually SN1, SN2, SNI, SNAR. Okay, not part 1. I mean, there is another one that we have done, which is alcohol, phenols and ethers, because you encounter elimination mostly in alcohol, phenol and ether. So alcohol, phenol and ether का भी हम part 1 कर चुके हैं, which has SNAR, which has E1, which has E2, and which has, no, I mean, I think we haven't done E1CB. So these are the named reaction, these are the reaction mechanisms that we have done already. So last week was all about the reaction mechanisms. So today you would see the job will become seamless for us. So आज हम haloalkanes and haloarenes करने वाले हैं along with the previous year questions. And certainly we will get a reality check of whether we are on a right track or not. So how I go about is, I know that if, let's say, there is a student who is not prepared well for haloalkanes, so my agenda is also to give you a bit of theory, because most of the mechanisms and understanding will be coming from these sessions that I've already conducted on the reaction mechanism. You will see that we are going to integrate those reaction mechanisms today with our chapter haloalkanes and haloarenes. Okay. Having said that, let me also tell you, next session will be alcohol, phenols and ether, which is on Friday. Then next chapter is going to be a huge long chapter which will be aldehyde, ketones and carboxylic acid. Then there is just nitrogen containing compounds. So by next week we will be completing our syllabus, right? So I am a 0 in organic. Sangram Jeet Singh Sahab, पहले तो H हट दे कि 0 बोलनी है, अपना 0 नहीं बोलना है. अपने आप को कभी भी अंडर एस्टिमेट मत करिए. Do not associate words like these for yourself. What is a 0? Nobody is a 0. Come on. Even if you know a bit of organic, that's not a 0. Even if you know कि organic चीजें बाहर सेल होती हैं या कार्बन कंटेनिंग कंपाउंड ऑर्गेनिक होते हैं, it's not a 0. So come on, stop saying that. Right? Let's not be a sadist. But yes, if you're starting with organic series, wonderful. They will really help you out. Just try it for yourself and you would know. I can assure you that. The one thing I can certainly assure is this is on YouTube. This is one of the most best quality content collaborated all together, being given to you free of cost with the great minds at work and amazing, amazing animations like you have observed. So with this, let's do a shubharamb. Let's get started. Preparation करते हैं. मैंने आपको बताया था तरीका of going about. The way you have to go about is every preparation method has to be written on one sheet, chemical properties on one sheet. So we have two agendas in this chapter, alkyl halide, which is Rx, and aryl halide, which is with the benzene, this X. So we have to do both. Let's start with the preparation of alkyl halide. We can do it from alcohol. Remember, we have done this. ROH can give us Rx, remember? And the different reagents that can be used when we are talking about from alcohol is you can use halogen acid like HX, you can use HCl for example. Okay, but don't forget that when you're dealing with a 1 degree or a 2 degree alcohol, ZnCl2 you have to use, right? ZnCl2 is used for the preparation from alcohol, and you know the name, huh? Lucas reagent. I hope this is visible. I'll get side. So you know when we are using HCl plus ZnCl2, this is Lucas reagent. Named reaction coming your way. Then there is phosphorus halides. Different phosphorus halides can be simply red phosphorus. You can use, or you may use let me say PX5, or you can use PX3. All these are phosphorus containing compounds, right? Or you can use thionyl chloride, SOCl2. If you remember, this is one of the best methods, and the mechanism under play was SNI, right? So Pratham is saying all the one problem I face is question related to only one part of organic. The problems which are combining other chapters I can do quite easily. I can do quite easily, or I can't do quite easily, because although is written, the language says something else and the statement says something else. So Pratham, if you're saying this quite easily, good for you. Congratulations. Nothing makes me happier. So yes, one thing which is a part of your practical organic chemistry syllabus also is how can we distinguish 3 degree, 2 degree and 1 degree alcohol. So the method that must strike the doors of your mind is Lucas test. If you remember, if you're taking Lucas reagent, which is nothing but HCl in the presence of zinc chloride, if you're taking Lucas reagent, if it is a 3 degree alcohol, because the mechanism is SN1 mechanism. And what happens in SN1 mechanism? A carbocation gets formed. If the carbocation gets formed, that means if it is a 3 degree alcohol, how will you get a 3 degree alkyl halide? Instantly. So there is instant turbidity. But if it is a 2 degree alcohol, then you would see if you add HCl in the presence of zinc chloride, the turbidity will appear, but it will take some minutes, right? So turbidity between 5 to 10 minutes. And if you would see, if you keep waiting and waiting, but there is no turbidity, then it is a 1 degree alcohol. So this is a test which is a part of your practical organic chemistry also. For the alcohols, one is a can test, for which I have already aired one shot, a YT shot for the can test. I hope that was helpful. The second test is this Lucas test, and third one is iodoform, which is majorly for the methyl ketone kind of species that we will be doing in aldehyde ketones. But for now, I am sure it is clear that there is also a 2 degree alcohol which is capable of giving iodoform. So I'll come to iodoform in a bit, but Lucas is also covered up now here, okay? With other phosphorus containing compounds, like for example PX3, P in the presence of X2 or PCl5, what you're getting is Rx. Bacha Party, if you see the trend says that the byproducts are also important. सो बाय प्रोडक्ट्स पे सवाल आए हुए हैं प्रीवियस ईयर में, इसलिए आपको ज़रूर समझना चाहिए कि बाय प्रोडक्ट क्या है इन सभी के. इनफैक्ट विथ thionyl chloride also the byproducts are equally important. So please see, when you're taking PX3, what you're getting is H3PO3, right? When you're taking red phosphorus in the presence of X2, all that you're getting is Rx, okay? I mean, the byproduct is there, but it is not important. This is important and this is important. Here what you have is POCl3 and HCl. So this is what you get. H3PO3, phosphorus acid, right? Not phosphoric. This is phosphorus, OUS. Phosphorus acid, right? So this is important. और ये भी आपको ट्रिक भी याद होनी चाहिए कि कैसे सारे के सारे एसिड्स को याद रखना है, राइट? सो व्हेन आई टॉक अबाउट दिस थिंग, अस एसिड, इक एसिड, so when oxygen, maximum number of oxygens are attached, we call it phosphoric acid. If let's say one oxygen you further add to it, H3PO5, it becomes per-phosphoric acid. I'll get a side. Per-phosphoric acid. If you remove one oxygen from it, it becomes us acid, right? And if you remove another oxygen from it, it becomes hypoous acid. So H3PO4, H3PO3, H3PO2. So H3PO2 becomes what? Hypophosphorus acid. So the entire game should be crystal clear for you, right? And when we are talking about this one, POCl3, we call it phosphoryl chloride. Is this visible here? Phosphoryl chloride. All these names can be asked in one form or the other. So the names are also important and their behavior is also important. So if I talk about thionyl chloride, if you remember SNI mechanism in the absence of pyridine, but in the presence of pyridine, it was SN2. So do not forget that. कैसे याद कर सकते हैं? आप लिख सकते हो ROH with SOCl2. So your byproducts are SO3, HCl and RCl. And you remember this is one of the best methods, like a 5-star method for the preparation of alkyl halide. Why? Because if you see, the two products are gaseous. And since it is gaseous, it will evolve out. And if it evolves out, that means the reaction will keep going forward thanks to Le-Chatelier principle. If the products decreases, reaction goes in the forward direction. All cool? All good? So far so good? Question देखें एक. Let's see. In the reaction ROH plus PCl5 giving us RCl, I was telling you this is important and all these are previous year questions only. RCl plus X, the byproduct formed is, tell me. So Krish is saying B, Shlok is saying B, Pratham is saying B, Mahendra is saying Dhoni. अरे वाह, धोनी साहब कभी कोहली साहब मिलने आते हैं, कभी धोनी साहब मिलने आते हैं. Wow यार, this is exciting for me. B, Arpita B, okay great. So I'm sure this is clear that with PCl5 you get POCl3, whereas with PCl3 you get H3PO3, right? So remember the byproducts, they can be asked as a question. अब सवाल ये बनता है मैम कहाँ byproducts हमें याद करने? Do we have to remember the byproducts everywhere? No. There's certain reactions जहाँ पे byproduct आपको याद करने, and that is where my role as a teacher comes in. So do not worry about remembering byproducts everywhere, but wherever I'm mentioning that byproducts are important, remember them. Okay? So yes, POCl3 becomes the answer, B becomes the answer. Next question. Which of the following is a good method for the conversion of an alcohol into an alkyl chloride? Come on, this we just discussed. We know the reason, we know whom to remember. Le-Chatelier principle must strike the doors of your mind. And if it does, I'm sure you know what to do. So examiner can be tricky by not saying SOCl2 but writing thionyl chloride. So the names also, like I mentioned, are important. So Naveen, absolutely right. Good Mahendra Singh, good Krish, absolutely right. A becomes the answer. So अभी हमने क्या किया? हमने किया preparation of in fact alkyl halide I would say, because we are just अभी talking about, we are not talking about aryl halide for now. So alkyl halide we are preparing from alcohol, and we can use HX in the presence of ZnCl2, HX, or we can use red phosphorus with X2 or PX3 or PX5, and we can use SOCl2. 3 methods from the alcohols should be clear. Right? Absolutely. So Ananta Krishna is saying SOCl2 reaction leaves only the desired product thanks to the 2 gases which are produced, which gets evolved out. So yes, this method is also called, what is the name of this method? Is it a named reaction? If it is a named reaction, what is the name of the reaction? I have told you this. The mechanism also, you know, SNI is the mechanism that it follows. But the moment pyridine is being used, the mechanism becomes SN2. So when we say SNI, retention of configuration takes place. All these points should come in your mind one after the other. Absolutely. So this is Darens reaction. Darens reaction or Darens process. Great. Next one is from hydrocarbons. This is pretty easy and not a very good method because we have discussed Friedel-Crafts. That's for aryl halide. Here we have done free radical, if you remember. Free radical mechanism we have discussed and we have talked about initiation. जैसे COVID फैला था, COVID कैसे फैला था? Initiation हुआ था एक lab leak या फिर like the controversy theories, a lab leak. The acceptable theories, it has come from the bats from the supermarkets of China, but everybody knows it's a hush-hush. So zipped here, but we know it initiated first. Then it propagated. It propagated like big time, like a wildfire. After propagation, because of vaccine, because of social etiquettes, what happens? There was a termination. Exactly what happens with the reaction here with the H nu X2 with alkanes. So if you remember H nu light या UV कुछ भी लिखा हो in the presence of X2 will give you different alkyl halide. You will get multiple products, and since multiple products is what you get, it is not a desirable method. अपन को क्या चाहिए होता है? अपन को चाहिए होता है feasibility, economical, अच्छा होना चाहिए, पैसा कम लगा के प्रोडक्ट हमें ज़्यादा मिलना चाहिए. This is our agenda, but this gives you multiple products, so not a very good method. From alkenes also we have done, if you remember, we have added HX, and when we added HX, we know we have talked about Markovnikov-Baba, Markovnikov rule. So HX is added in terms of Markovnikov rule. ठीक है? So let's look at this once again. इसमें important एक और layer add कर देती हूँ अब मैं. So when we are talking about addition of X2, so when we are talking about addition of HX, we get in alkene what we get is HX gets added, right? So it gets added according to Markovnikov rule. But when we add X2 in the presence of, let's say, chloroform or CCl4, what gets added is, what you get is a vicinal dihalide. So vicinal dihalide समझ रहे हो ना, दो halogens एक दूसरे की vicinity में है. In that case, do remember that when we add X2 in the presence of chloroform or CHCl3 in alkene, what happens is anti-addition takes place. Anti-addition. So, if your starting alkene is a cis or a trans, will it make a difference? 100%. What difference will there be? When you have a cis alkene and you're adding X2 and you're doing this anti-addition, you will see that you get racemic product. Racemic product. What is a racemic mixture? If there is one product which is being formed which is rotating the plane of the plane polarized light clockwise, the other one is rotating the plane of the plane polarized light anti-clockwise. So racemic product is what you get. Overall mixture is optically inactive. 50-50% मिल गया दोनों का. But when we talk about trans, then if you do anti-addition, what you get is a meso compound. Okay, again optically inactive overall because of the internal compensation. Absolutely. So what I'm trying to come to is what Shlok Parekh has written very well, car-tram. That's the trick to remember. Car-tram. Cis alkene, anti-addition, racemic product. Right? Whereas if you're taking transalkene and doing anti-addition, what you get is a meso compound. Meso compound, you know, are those compound which has elements of symmetry, specifically plane of symmetry. So because of the internal compensation, it becomes optically inactive, right? So car-tram, if you observe, ये cis alkene था, bromine डाला, तो ब्रोमीन इस तरीके से ऐड हुआ कि एंड इट इज एंटी एडिशन, तो एक ब्रोमीन ऊपर है, एक ब्रोमीन नीचे है, या फिर हम ऐसा कह सकते हैं वन ब्रोमीन इज अबव द प्लेन एंड द अदर ब्रोमीन इज इनसाइड द प्लेन, एंड it can be vice versa. This bromine which we made below the plane is now above the plane. So these two are the possibilities. Both can be formed, and if one is going to be, let's say, RR, the other one is going to be SS. So overall this is a racemic mixture, right? And if you're talking about a transalkene, you would see what is happening. You're getting a compound which is having a plane of symmetry, and if you make a mirror image of this meso compound, the other compound that you get is also what the other compound that you get is also identical, right? So Rohan, ये कैसे होता है? ये cyclic brominium ion बनता है. You get a cyclic intermediate, and that is the reason why it is anti-addition. So what happens is, let's say one bromine comes in. Let's take a cis wala case to understand it better. Let's take it like this. So one bromine comes in and adds, and you can get a cyclic intermediate, cyclic brominium ion. Now if you see, it is very difficult for the other bromine to come and attack from this side. So rather it comes and attacks from the other side. That's why it's an anti-addition. So cyclic brominium ion is the intermediate when you're taking Br2. Cyclic chlorinium ion will becomes the intermediate when you're taking Cl2. Okay, so car-tram is an important concept to remember here. बताया ना ये intermediate ये बच्चे, शीतल, this is the intermediate, Br with a plus, cyclic brominium ion. I'll write it. Okay, now a question coming your way. Let's see if you can do it or not. Tell me. So Sheetal, you must know which addition, when addition is anti and when addition is syn. For example, with KMNO4, when we were talking about, it was a syn addition. If we are talking about catalytic hydrogenation, it was a syn addition. Here it's an anti-addition. So you must know when is what. Yes, Pratham, that's what I just mentioned, Hana. It is a syn addition, correct. So what trick you apply? Car-tram. Car, the moment you see cis, okay, though it is an asymmetric cis compound, so C, anti-addition, racemic, so you get a racemic mixture, so B becomes the answer. Directly using the trick you're doing it, easy for us, good for us, simple. Next one. The product formed when 1,2-dimethyl cyclohexene is treated with HBr. So with HBr, if you remember, it was a simple Markovnikov rule. Only with X2 बच्चों आपने करा है car-tram का फंडा. Otherwise, please do not apply दिमाग अलग से, कहीं भी नहीं लगाना है. उससे अच्छा है ignorance is a bliss. जिसको नहीं पता है car-tram, वो ऐसा सवाल ज़्यादा अच्छा कर रहा होता है. So it's a simple Markovnikov rule that you have to apply. One 2-dimethyl cyclohexene is treated with HBr is. ओके, सो धोनी साहब कह रहे हैं सी, अजय प्रताप कह रहे हैं सी, क्रिश इज सेइंग डी, ज्योति वर्मा इज सेइंग सी, एडू एक्सप्रेस इज सेइंग सी. हाँ, स्टेबल कार्बोकेटाइन बनाओ फिर. क्रिश इज सेइंग डी, शीतल इज सेइंग सी, अर्पित सी, आई एम सी, ध्वनित is saying C, no life, no life Kaneki, C. Okay, so is it clear that when we are talking about this compound cyclohexene 1,2-dimethyl, तो यहाँ पे CH3 है, यहाँ पे CH3 है, so if one bond comes here, minus comes here, plus comes here, so with minus you give an H, and this is a very stable carbocation. There is no possibility of any shift or rearrangement, so the bromine will come and attach here. Now there are both the possibilities. This bromine can be above the plane and this hydrogen can be attached below the plane, or it can be bromine and below the plane and hydrogen above the plane. So both the possibilities are there. So trans bromo 1,2-dimethyl cyclohexene is not possible at all. B is ruled out. Hexene तो गया ना, हमारा addition हो रहा है, तो hexene is no more going to be hexene, right? So 1-bromo 1,2-dimethyl cyclohexane, both cis and trans. Very good, ना? Look at this. हमारा hexene ये गलत है. So 1,2-dibromo, this is also wrong. Oh, lovely. So by mistake, I think all the options are wrong, which you should have given me as your answer. I mean, this is a one that will go to NTA because all four are wrong. So the answer would have been correct if we had hexane written here, cyclohexane. C is absolutely fantastic option here to choose in. Sheetal, it was had it been not hexane written. Hexane should have been written. That's uncompromisable, right? 1,2-dibrommethyl hexane. ये सही लग रहा है hexane देखने की वजह से, but again the question had an error. But yeah, it stands corrected now. So please be careful, be mindful about all the mistakes that can be there, है ना? अपनी तरफ से आंसर हमें सही देना. अगर C मेंशन करो तो you mention that it should be cyclohexane. Mention the mistake also. So 1-bromo 1,2-dimethyl. So 1-bromo, your numbering will start from here. 1,2-dimethyl cyclohexane, both cis and trans. Absolutely. So this is possible, and both bromine and hydrogen are above the plane. That's also possible, right? हाँ, तो बोनस मिलेगा. बट यहाँ पे अभी बोनस नहीं मिल रहा है. यहाँ पे अभी आपका अंडरस्टैंडिंग चेक हो रहा है कि कितने माइंडफुल हो, कितने अच्छे से सवाल कर रहे हो. तो सी बस आंसर कर देना मतलब नहीं है. अगर ऑप्शन ही आप नहीं पहचान पाए कि ये गलत है, ऑप्शन गलत है, ये भी आपको पहचानना है. ठीक है, तो अब हेक्सेन कर दिए तो सी सही आंसर है. करेक्ट. तो क्या किया अभी तक हमने किया फ्रॉम अल्कोहल एल्काइल हैलाइड बना लिया. अल्कोहल लिया था तो सबसे पहला मेथड, यू कैन यूज HX, यू कैन यूज SOCl2, you can use red phosphorus, you can use PX3, you can use PX5. So ये हुआ आपका from alcohol. Then second method you can use is from hydrocarbon. Hydrocarbon के अंदर HNu in the presence of X2 डालोगे तो free radical mechanism से आपको CH3X, CH2X2 ये सब मिलता रहेगा. In fact जब हम बात करेंगे इसकी हाइड्रोकार्बन्स की तो एल्कीन भी यहाँ पे आता है. एल्कीन में आप अगर सिर्फ मोनो एल्काइल हैलाइड चाहिए तो HX डालेंगे अकॉर्डिंग टू द मर्कोनिकॉव रूल. अगर विसिनल डाई हैलाइड चाहिए तो आप X2 डालेंगे. X2 इज sin or anti. You have to remember it's an anti addition. The other thing that you have to remember is car-tram. I hope everything is now sorted so far. Next one is from halogen now. Halogen में यहाँ पे आ गए हैं named reaction बचा पार्टी. And you know when named reactions come, you have to salute them. You have to give them respect in your holy notebook of named reactions. ठीक है? So Sheetal, next session actually is about alcohol, phenols and ether के सारे सवाल. PYQs I'm going to come up for alcohol, phenols and ether in the next session. Aldehyde, ketones and carboxylic acid is going to be a long session. I'm trying to take out 3 hours, and in one marathon series I'm going to cover aldehyde, ketones and carboxylic acid. So Sheetal, that's the agenda for the next session. Okay, from halogen you have 2 possibilities. One is Finkelstein, other one is Schwarz. Finkelstein reaction बच्चा पार्टी पता होना चाहिए, Schwarz reaction पता होना चाहिए. Finkelstein F से start हो रहा है. Remember, product doesn't have F. Right? F जो F से start हो रहा है उसमें fluorine नहीं लग रहा है. You can start with any alkyl halide but you will get Ri. तो remember नाई use करें, नाई. Everybody knows Hindi, huh? Those who do not know, नाई is what? You can just remember the name नाई. नाई is barber. In English, barber. Okay, Hindi में नाई. तो remember नाई. N-A-I, the product will have I. So Finkelstein loves to go to the barber. Something like that. I mean, make up stories so that you remember things. Okay, you remember stuff which will stay in your head. Make a story somewhere, make an acronym somewhere, make logical answering somewhere, or remember just the concept somewhere. So you have to mix and match stuff so that things stay with you. It might not be a very fantastic trick, but it is something that should stay with you because you can't do such things wrong. Okay? No life करने की एक बारी एक काम करियो, पीछे जाइयो, रिकॉर्डिंग देखियो, कार्टरा में दिक्कत आएगी तो बताइयो, अगले सेशन में I'll take it up. So you do it as a homework. Cartram is a very simple thing like we have discussed. Cis, anti-rhythmic, trans, anti-meso. इतना खोजा कितना खोजा होता तो यही मिल जाती ना, love physics, love nature. ओके, सो कभी भी अब ये सवाल आ रहा है कि ड्राई ईथर, ड्राई एसीटोन, तो प्लीज मेक श्योर सोडियम अपना बॉम्ब बंदा है यार अपने केमिस्ट्री में. यू नो दैट इट इज famous for bombardment. It does a bombardment, right? Remember the small grain particle caused a bombardment on the face. Just doing this and there was a reaction. So we do not want any bombardment. We want to play it safe. So we carry it out in dry acetone. In fact, you have seen Wood's reaction also, that's carried out in dry ether. Whenever you would be seeing sodium, we will always be using inert solvents. Logical. Right? Now, Ni is clear. Sodium iodide you add in the Rx, and the moment sodium iodide is coming in or any sodium compound is coming in, you're using a solvent which is inert in nature, and what you get is Ri. So Rx is getting converted to Ri. Say RCl you're starting with, you're adding NaI. What you get is Ri, and NaCl gets precipitated out, right? Chalo. Now, Schwarz reaction में, please remember, Finkelstein में, like I said, iodine product मिलता है आपको, but Schwarz में क्या product मिलता है? Fluoro product. भाई थामा यार, इतना एक ही चीज 100 बारी लिखना is not a right etiquette. Let's understand the social etiquettes. When we are learning on social media, when we are learning on YouTube, there are certain social etiquettes that we must follow, please. Okay, so RBR in the presence of AGF gives you RF plus AGBR. Now, please remember, it's not silver fluoride that you can use. Schwarz में फ्लोरो मिलता है, फिंकलस्टीन में फ्लोरो नहीं मिलता है. F से जो स्टार्ट हो रहा है उसमें आइडो मिलता है, नाई. फिंकलस्टीन loves to go to barber. नाई, NaI. So remember, यहाँ पे AgF की जगह there can be other things also. What can be asked? सबको silver hug. Not a golden hug. सबको silver hug. So sub is antimony Sb, co is cobalt, silver is Ag, hug is Hg. So all these fluorides. So when we have Sb plus 3 is most stable, right? So SbF3, cobalt का CO2 plus, so COF2, AgF, Hg2F2. So सबको silver hug से याद रख सकते हो, इनमें से कोई भी हो that can be used, and this is a possible question in itself, that which of the following can be used in preparing alkyl fluoride? Option A, SbF3, option B, COF2, AgF, option D, all of these. So all of these becomes your answer. Okay, so Dhwanit is asking, ma'am, if we add acetone and pure ethanol, acetone or ethanol mila diya and boil the solution, then acetone will evaporate easily. So it's a very beautiful question which belongs to actually the purification techniques, and which is a part of your practical organic chemistry. And all these separation methods we have to do. अगर एसीटोन में अल्कोहल मिक्स हो जाए तो, एसीटोन में एनालीन मिक्स हो जाए तो, अगर दो पेट्रोल प्रोडक्ट्स एक दूसरे के साथ मिक्स हो जाए तो, so these are the things that we have to do in fact in detail. So we'll come up with all the possibilities and we'll talk about it. ठीक है, चलो अब आते हैं प्रेपरेशन पे ही, बट अराइल हैलाइड की प्रेपरेशन पे, जो कि हम कर चुके हैं, सो इट विल नॉट टेक अस वेरी लॉन्ग. फर्स्ट इज अ डायरेक्ट हैलोजिनेशन. डायरेक्ट हैलोजिनेशन जब हम देख रहे हैं तो हमारे पास टोलुइन है, हम इसमें डालेंगे X2 in the presence of iron, we get what? Halo compound, haloaryl. Para is going to be major, para major होने वाला है, right? And this is the easiest step. हाँ, डाइसोनियम से भी तो बना सकते हैं F compounds. तनिष, फ्रॉम डाइसोनियम सॉल्ट्स अराइल हेलाइड जरूर बना सकते हैं, नॉट एल्काइल हेलाइड. या वी कैन मेक अराइल हेलाइड, वी कैन नॉट मेक एल्काइल हेलाइड. करेक्ट. So look at this, disonium salt use करते हैं, which is nothing but benzene N2X minus. So when we are taking this benzene N2 plus X minus, we know that if we take, let's say, Cu2Cl2 in the presence of HCl, ये नाइट्रोजन बाहर निकल जाएगा, नाइट्रोजन गैस बाहर निकल जाएगी, N2 will be evolved out, and what you will get is chlorobenzene, right? Similarly, you can do the other one also, Cu2Br2. So if you see, copper here is in +1 oxidation state, yeah? So what you will get is a bromobenzene, and N2 will be evolved out. Right? Here you can take it in the presence of HBr. Named reaction बच्चा party, Sandmeyer reaction. So 3 back-to-back reactions हो गए हैं which are named reaction. Number 1, we have seen Finkelstein where we get ido compound. The other one we have seen is Swartz reaction where we get fluoro compounds using subco silver hug. And here Sandmeyer we are getting chlorobenzene or bromobenzene, an aryl halide basically from disonium chloride. And Gattermann reaction, अगर हम बात करें तो it is very similar to the Sandmeyer reaction. If you see Cu2Cl2 plus HCl है, यहाँ पे copper लेते हैं in the oxidation state 0 with HCl, या फिर copper ले सकते हो with HBr. You will get again the same compounds. You will get chlorobenzene, you will get bromobenzene here, but there are other products also. So N2 gas will be evolved out, and along with that you will get Cu, Cl, and you will get CuBr. ठीक है? So 4 named reactions have come your way. If your intention is to create idobenzene, then good for you. Idobenzene में, हाँ, can we use HBF4 for getting fluorobenzene from disonium salt? We'll talk about it. ठीक है, अभी इसके बारे में मैं बात नहीं करना चाहूंगी डाइजोनियम के बारे में. लेट मी टॉक इवन फर्दर. ऑफ कोर्स दिस इज ऑल्सो नेम्ड रिएक्शन इफ यू रिमेंबर, राइट प्रथम, बट दैट बिलोंग्स टू द चैप्टर amines. So let's take it there. अभी NCERT के हिसाब से let's move. So in NCERT we have Sandmeyer and Gatterman for diazonium salt in this chapter. Let's just simply keep this for now. You're right, HBF4 also is a part of your syllabus, but amine. So we'll do it there. Now here N2Cl अगर मैं ले रही हूँ बेंजीन के साथ, Ki डाल दूँ simply, shaking it with Ki बच्चा, है ना? श्लोक HI नहीं, Ki. Potassium iodide. Then what will happen? Simply this N2 will be removed and you will get ido compound here, and this is easy method. You do not need, no need of cuprous halide. Right? Simple Ki would do. Alright, let's see whether you can remember things or not with this question. Now, the question is, the chlorobenzene is generally obtained from corresponding diazonium salt by reacting it with not idoform, Dwanit, only Ki in this reaction for BDC, benzene diazonium chloride. अभी बाल शीमन ये सब आएंगे. बाल शीमन and all the other named reaction we will be doing in amines, not right now. So cool, this is super cool. I think it is clear. Cu2Cl2, the moment you see it, the named reaction that should strike the nose of your mind is, what is the named reaction? कॉपर जब जीरो ऑक्सीडेशन स्टेट में है तो क्या है, और कॉपर जब +1 ऑक्सीडेशन स्टेट में है तो क्या है. ये दोनों के लिए ये अपने आप में ही सवाल है. सो व्हेन वी हैव कॉपर इन +1 ऑक्सीडेशन स्टेट, दिस इज वेयर यू हैव सीन इट, सैंडमेयर कॉपर +1, and when you have seen copper in zero oxidation state, that is Gatterman. So Sandmeyer, Gatterman. These are again potential questions in themselves. Now let's move on to the chemical properties. Good. ठीक है, याद हो रहा है? I hope this is staying here. ऐसे तो नहीं निकल जा रहा है ना एकदम. वो है ना डायामैग्नेटिक वाली जो मैग्नेटिक फील्ड दिखाते हैं, यूं करके निकल जाता है, वैसा तो नहीं निकल जा रहा है भेजे से, ऐसे करके गायब हो जा रहा है डायामैग्नेटिक की तरह, या अंदर से पेनिट्रेट होके जा रही हैं चीजें. ऑल कूल, सब चंगा, करें आगे शुभारंभ. चलो केमिकल प्रॉपर्टीज देखते हैं अब हैलोएल्केन्स की. ये तीनों हम देख चुके हैं. इनफैक्ट वी हैव सीन न्यूक्लियोफिलिक रिएक्शंस, न्यूक्लियोफिलिक सब्स्टिट्यूशंस टू बी प्रिसाइज. We have seen elimination, we have seen reaction with metals. Let's just recap them very quickly. डाइपोल मोमेंट, कौन सा डाइपोल मोमेंट बचा श्लोक? हाँ, ये जरूर हमारे सिलेबस से, केमिस्ट्री सिलेबस से जा चुका है. पैरामैग्नेटिक, डायामैग्नेटिक, दिस इज नो मोर अ पार्ट ऑफ योर सिलेबस. इट इज नाउ इन फिजिक्स ओनली. केमिस्ट्री में वैसे भी सवाल नहीं आ रहे थे. जब भी सवाल आ रहे थे डायामैग्नेटिक, पैरामैग्नेटिक, फेरोमैग्नेटिक, फेरीमैग्नेटिक, एंटी फेरोमैग्नेटिक, ये सब आ ही रहे थे फिजिक्स में. सो अब वो है ही नहीं. देयर इज नो डुअलिटी नाउ. चलो, good to hear that श्लोक, that it will stay there only. Good to know that. चलो अब हम बात करते हैं न्यूक्लियोफिलिक सब्स्टिट्यूशन की. ये हम देख चुके हैं. इफ यू रिमेंबर, इफ वी टेक हैलोअराइल एंड, हाँ, तो ये तो श्लोक RX RCl, ये RF, ये तो केमिकल बॉन्डिंग हो गया ना. ये तो आपको पता ही होना चाहिए बिल्कुल. नो देयर इज नो मिक्सिंग. That's inorganic, this is organic. No mixing about it. ठीक है, चलो. CH3 3CBr OH minus H2O की प्रेजेंस में हम देख चुके हैं कि अल्कोहल देता है. हम यहाँ पे माइंड यू एक्वस KOH यूज कर सकते हैं एज अ reagent. Okay, so that OH minus will act as a nucleophile. We do not want KOH as a conc KOH या फिर alcoholic KOH, ये लिखा हुआ है मतलब कि एलिमिनेशन होगा. एक्वस KOH होना बहुत जरूरी है. ठीक है. VBT देखो ध्वनित पता होनी चाहिए. VBT इज वेरी क्रूशियल. सिलेबस में हो नहीं हो, इट इज स्टिल अ पार्ट ऑफ योर knowledge. Otherwise you can't do chemical bonding. So VBT आपको पता होना ही मांगता है. And coordination chemistry में तो VBT वैसे भी है ही, right? Okay. Now as a base नहीं चाहिए. बिल्कुल सही तनिष. So हमें यहाँ पे क्या करना है? Substitution. So we want it as what? As a nucleophile. So either you can use a weak nucleophile. You may not use OH minus, or you may use aqueous form of OH minus. That you need to be careful about. And ये हम पूरा mechanism कर चुके हैं. First form. So this is going to be proceeding via SN1 mechanism. When we talk about SN1 mechanism, first step is the formation of carbocation. Second step is the attack of the nucleophile. We have done this very well. The previous last to last session was all about this. In case you missed it, please watch the session. SN2 mechanism also we have done. For example, let's say I have 1 degree alkyl bromide, and to it I am adding a base, a strong base mind you, or a strong nucleophile in this case. Strong nucleophile we are adding to a 1 degree alkyl halide. In fact, this is a methyl bromide. This is not even a 1 degree. This is a methyl bromide. What you get is a product where nucleophile will get substituted, and this is exactly another named reaction coming your way, Williamson ether synthesis. So Williamson ether synthesis is following what mechanism, bacha party? SN2 mechanism. What are we taking? We are taking an alkyl bromide, and what are we taking? This is in a general scenario when we have an alkyl halide which is a smaller alkyl halide, like a methyl alkyl halide here, with a strong nucleophile. You can see how strong it is because of the plus I effect. There is high electron density on oxygen, right? So what will happen? You can just remove NaBr and combine the rest together. So what you get is an ether. So this is alcohol, phenol and ether. Maybe we make use of this, right? बिल्कुल. So ध्वनित is saying, मैम alkene बनाएंगे तो हमें alcoholic KOH चाहिए रहेगा. Yes. अभी हम क्या कर रहे हैं? SN1 का revision. SN1 में हमने देखा कि हमारे पास या तो weak nucleophile हो जैसे कि water, या फिर OH minus aqueous में भी हमारा 3 degree alkyl halide लेकर काम कर रहे थे तो काम हो रहा था. But if we are talking about methyl halide like this and taking a sodium sodium tertiary butoxide here, what will be happening is mechanism which is SN2. In fact, the two named reaction bacha party that we have done, this is Finkelstein, this is Williamson. In fact, Finkelstein reaction that we have seen, Finkelstein goes to Barber, NAI, NAI, I wala product, that one. So Finkelstein भी SN2 प्रेफर करता है. स्वाट्स रिएक्शन, ये जो सारे के सारे हैलोजन एक्सचेंजेस हो रहे हैं ना, एक हैलोजन की बजाय दूसरा हैलोजन आके बैठ रहा है, ये सब SN2 मैकेनिज्म प्रेफर करते हैं. स्वाट्स रिएक्शन आल्सो फॉलो SN2 मैकेनिज्म. सी मैकेनिज्म कर लिया तो अब बस हमें अपने दिमाग में फिट करना है एक जिक्सॉ पजल की तरह कि कौन क्या है. बस SNAR भी हम बहुत अच्छे से कर चुके हैं. SNAR, if you remember, हमारे पास इलेक्ट्रॉन विड्रॉइंग ग्रुप्स लगे हैं ऑर्थो या पैरा पे विद अराइल हेलाइड. देन द अराइल हेलाइड बिकम्स एक्टिवेटेड टुवर्ड्स SNAR. ठीक है. सो यहाँ पे अगर 40 डिग्री भी डालोगे, पानी ही लोगे बस, तो भी आपका रिएक्शन हो जाएगा. व्हाट यू गेट इज अ पिक्रिक एसिड. इफ यू रिमेंबर, NO2 NO2 NO2, दिस इज नथिंग बट पिक्रिक एसिड. This is nothing but 2,4,6 trinitrophenol, right? Pratham is asking, ma'am, the alkyl halide which we take for this reaction has to be 1 degree or 2 degree, right? Because 3 degree alkyl halide prefers to form alkene. Bilkul. So, Pratham, this I already told you there are many layers added to one particular reaction. अगर हमारे पास ऐसा reaction है जो कि कार्बोकेटायन नहीं बनाएगा और ट्रांजिशन स्टेट ही बनाएगा, तभी आप SN2 बोलोगे. अगर किसी भी तरीके से पॉसिबिलिटी लग रही है कि कार्बोकेटायन बनने की संभावना है, then you will not go with SN2 mechanism. You will go with SN1 mechanism, right? Okay, so this was SNAR. We've also done SNI, remember, internal SOCl2, the Darens reaction. SOCl2 अंदर से ही देख लो, यहाँ पे हमारे पास अल्कोहल था, SOCl2, क्लोरीन जो है लगेगा. जब क्लोरीन लग गया, वो जो क्लोरीन था लगा हुआ डायरेक्टली अटैच्ड, वही अटैक कर लेता है उसी साइड से. The SO2 leaves, and if you remember, you were getting the same configuration as the starting compound. So this was with without the presence of pyridine. With the presence of pyridine, it is SN2. There will be inversion of configuration in that case. Then comes SNNGP. NGP हमने नहीं किया है. So it is time for us to know it very well. Neighboring group participation. क्या है ये neighboring group participation? मदद करेंगे पड़ोसी. पड़ोसी मदद वैसे भी करते हैं. अभी आई थिंक इतना नहीं पता हो कि कितने पड़ोसी काम आते हैं, बट हाँ, अपने पेरेंट्स से पूछना. पेरेंट्स को पता है पड़ोसियों की कीमत. रिश्तेदार से ज्यादा इंपॉर्टेंट बन जाते हैं एक टाइम बाद पड़ोसी, है ना. अभी तो ऐसा माहौल है इन द सिटीज लाइक बैंगलोर, we even don't know who our neighbors are. I mean, our generation is losing it all. But we know the value of neighbors. Ask it from the parents. They would know it. Neighboring group. यहाँ पे भी यही हो रहा है. क्या हो रहा है? बगल वाला एक ग्रुप होने वाला है जो क्या करेगा? मदद करेगा. कैसे मदद करेगा? अगर लेट्स से ये लीविंग ग्रुप है, तो ये लीविंग ग्रुप को कहेगा कोई बात नहीं, तू चला जा, मैं हूं संभालने के लिए. राइट? क्लासिक पड़ोसी केमिस्ट्री. दिस इज अ क्लासिक पड़ोसी केमिस्ट्री. हाँ, तो दिस इज अ क्लासिक पड़ोसी केमिस्ट्री हियर कि लिविंग ग्रुप कह रहा है कि हाँ तू कोई बात नहीं, तू चले जा, मैं हूं ना ध्यान रखने के लिए. आई विल टेक केयर ऑफ योर हाउस, डोंट वरी अबाउट दैट. तो ये गया और इसने क्या किया? इसने मदद कर दी यहां पर थ्रू इट्स लोन पेयर. सो यू वुड सी दैट दिस पर्टिकुलर एटम मस्ट बी ऑन द, तो ये लीविंग ग्रुप है तो ये अल्फा, ये बीटा. बीटा पे होना चाहिए हमारा ऐसा ग्रुप लगा हुआ जो कि मदद कर पाए. अपने केमिस्ट्री में कौन मदद कर पाएगा? ऐसा स्पीशीज जिसके पास लगा हो लोन पेयर. ठीक है, लोन पेयर होना जरूरी है या माइनस चार्ज होना जरूरी है. सो इफ लेट्स से सल्फर ले हम, लाइक हियर इफ यू सी सल्फर विद द लोन पेयर, तो आप देख लीजिए लीविंग ग्रुप यहां लगा हुआ है. दिस क्लोरीन, द हैलोजन इज गोइंग टू बी आवर लीविंग ग्रुप ऑलवेज. दिस बिकम्स अ अल्फा कार्बन, दिस बिकम्स अ बीटा कार्बन. बीटा पे लगा हुआ है लोन पेयर, राइट? सो यहां पे ये गया और इसने कहा कि कोई बात नहीं, तू जा, मैं हूं ना संभालने के लिए, मैं हूं ना. Oh, ध्वनित, I'm like leaving group, सब छोड़ के चले जाते हैं. I can hear him talking also. ध्वनित यार, cute. Okay, नई पड़ोसी कैसे भी हो पर सब हेल्प करते हैं. महेंद्र सिंह को बड़ा मजा आ रहा है. Very nice. We can see his पड़ोसी chemistry here. हाँ, ऋषभ बहुत जल्दी आया आज. कहानी खत्म होने को है, अब आप आ रहे हो. सो आई एम श्योर दिस इज क्लियर कि क्या होना मांगता है. लीविंग ग्रुप हमारा हैलोजन होगा क्योंकि अल्काइल हैलाइड हमारा टॉपिक है. हैलोजन के बीटा कार्बन पे कोई ऐसा एटम लगाना चाहिए जैसे कि ऑक्सीजन, जैसे कि सल्फर, जिसके पास लोन पेयर है, जैसे कि नाइट्रोजन. तो जैसे ही लीविंग ग्रुप जाएगा, जो लोन पेयर है वो अपना लोन पेयर देकर जो डेफिशिएंसी क्रिएट हुई है लीविंग ग्रुप के जाने की, उसको कवर अप करेगा. और ये पड़ोसी की मदद बहुत लंबे समय तक नहीं चलेगी. क्या हुआ? फिर न्यूक्लियोफाइल आया, न्यूक्लियोफाइल वापस वहीं पे लग सकता है जहां पर हमारा लीविंग ग्रुप लगा हुआ था, या फिर बिकॉज इफ यू सी इन द प्रोसेस देयर इज अ साइक्लिक इंटरमीडिएट विच इज फॉर्म्ड. Sulfur, since it is making 3 bonds, it gets a plus here. So if you observe, ये वापस यहाँ पे आया, right? तो यहाँ से टूट सकता है. Look at this. There are two possibilities. ये अगर यहाँ से टूटा, let's say this is possibility A. यहाँ से टूटा, तो OH minus यहाँ पे आके लगा, and this is a starred. ये बीटा कार्बन, if you see, मैंने स्टार लगाया हुआ है यहाँ पर. राइट और यहां पे स्टार लगा हुआ है यहां पर. तो हमारा जो CH2Cl, ये क्लोरीन जो लगा हुआ है इस वाले कार्बन से लगा हुआ है, तो जो ओरिजिनली कार्बन लगा हुआ है उसी पे ये OH लग सकता है, ये भी एक पॉसिबिलिटी है. या फिर क्योंकि अब ये साइक्लिक इंटरमीडिएट है एंड इट कम्स इन ऑल अ प्लेन, एंड सिंस इट इज नाउ इन अ प्लेन, देन OH माइनस कैन equally probably attack from this side also, this B side, so that this breaks and ये स्टार वाला कार्बन यहां आ गया एंड OH यहां आ गया. सही है. तो नेबरिंग ग्रुप पार्टिसिपेशन मोहम्मद सैफ को सबसे ज्यादा जल्दी याद होगा, और मोहम्मद अपने पापा का नंबर जरूर दे दीजिएगा, जरा बता दें उनको कि चांद का टुकड़ा जो सामने रहता है उसकी वजह से ही मार्क्स नहीं आ रहे हैं. ये बताना बहुत जरूरी है, कहीं पता चले वहां पे दीवार लगा दी गई है अब. सो नेबरिंग ग्रुप पार्टिसिपेशन में मेन चीजें क्या क्या हो रही हैं, कैन वी जस्ट रिकैप्चुलेट दैट. वी नीड टू हैव अ लीविंग ग्रुप व्हिच इज गोइंग टू बी आवर हैलोजन. बीटा कार्बन पे देयर हैज टू बी some atom attached which is capable of donating the lone pair, like nitrogen, like sulfur. In fact, it can be a phenyl group also. Benzene के pi bond can also act like that. Also, अगर आप देखिए एक साइक्लिक इंटरमीडिएट बन रहा है, जिस कार्बन पे हैलोजन लगा हुआ था, लीविंग ग्रुप लगा हुआ था, उसी कार्बन पे अगर हमारा OH लग रहा है, दैट इज ऑल्सो अ पॉसिबिलिटी, या न्यूक्लियोफाइल लग रहा है, दैट इज ऑल्सो अ पॉसिबिलिटी, या उसके बगल वाले कार्बन पे लग रहा है, दैट्स ऑल्सो अ पॉसिबिलिटी, बिकॉज एट द एंड ऑफ द डे वी गॉट अ साइक्लिक इंटरमीडिएट, राइट. सो दिस काइंड ऑफ अ पड़ोसी की हेल्प, like why is it a separate reaction altogether? We saw that such reactions were taking place at 600 times farther speed as compared to a normal reaction when there was no such atom attached, no such padosi which was capable of giving a lone pair, when there was no such neighbor. Simple इस तरीके का अगर रिएक्शन ले CH3 CH2 Cl, देखा गया कि रिएक्शन होता ही नहीं है न्यूक्लियोफाइल के साथ, OH माइनस के साथ. बट जैसे ही यहाँ पे हमने एक ग्रुप लगा दिया विच इज केपेबल ऑफ डोनेटिंग अ लोन पेयर, एवरीथिंग बिकेम faster, very very fast, like 1200 times fast, lakhs of times fast sometimes. So there must be some other phenomena at play, and that is what we refer to as neighboring group participation. SN NGP should be clear now. NGP, neighboring group participation, कहाँ से आ रही है? एक बीटा कार्बन पे लगे हुए एटम से जो कि केपेबल है अपना लोन पे डोनेट करने में. आई होप इट इज क्लियर, लाउड एंड क्लियर. नेक्स्ट, एलिमिनेशन. एलिमिनेशन भी हम देख चुके हैं, अल्फा एलिमिनेशन, बीटा एलिमिनेशन, साइक्लाइजेशन. 3 टाइप की एलिमिनेशन पॉसिबल है. अल्फा एलिमिनेशन कार्बीन बनता है, रीमर टीमन इज द ओनली रिएक्शन विच इज अ पार्ट ऑफ योर सिलेबस दैट वी विल डू इन द next to next chapter, aldehyde ketones and carboxylic acids. Beta elimination is major one for our haloalkanes and haloarenes. We have seen E1, E2, E1CB and EI. E1CB we haven't, so we will see it right now. E1, if you remember, 3 degree, 2 degree, 1 degree, this is the order carbocation formation takes place, and then there is beta elimination. Beta hydrogen gets subtracted by the base. So you know that if I'm talking about this kind of a reaction, so first process will be the formation of a 3 degree carbocation, and then the base will abstract the beta hydrogen to form alkene. This is your E1 mechanism. E2 में everything is very similar. All that is happening is it's going to happen simultaneously. Beta hydrogen, and that too anti-beta hydrogen, the hydrogen which is at anti position with respect to the leaving group, is going to be eliminated. Okay, so what you get is RO minus Na plus. If you're taking, which is a very strong base, what you will get is an alkene, right? So dehydrohalogenation is what we are doing here, and E1 and E2 दोनों हो सकते हैं depending on what we are starting with. So be careful, right? E1CB. Now we have not done that. Jeffrey, I'll keep you posted on this. एक बार ये खत्म करते हैं. I have a lot of questions, previous year questions for you. So let me come back to that, and then I'll come to Nitika chapter and the New Year surprise Rushabh. I'll just come to that. ठीक है, इसको एक बार खत्म करते हैं because I have a lot of questions with me that I want you guys to solve. Let's see, E1CB if we talk about. So we have fluoro and NO2. Look at this. Leaving group है हमारा fluoro. Just like in SN-NGP जहाँ पे पड़ोसी मदद कर रहा था जब लीविंग ग्रुप जा रहा था by making a bond and cyclic intermediate बन रहा था, this was making the entire process faster. जो कार्बोकेटायन बनता, जो वो डेफिशिएंसी आती उसको तुरंत ओवरकम कर ले रहा था जो पड़ोसी है. क्या हुआ? कुछ नहीं, पेरेंट्स गए थे हेल्प करने के लिए, पड़ोसी आ गए कि खाना हम भिजवा देते हैं, और खाना हम भिजवा देते हैं तो अलग बात है, इतना स्वाद खाना भिजवा रहे हैं वो कि you're not missing parents going out. The पड़ोसीज are so helpful, the neighbors are so helpful. So I'm sure here you can make a contrast that with E1CB it's opposite. Again, if you see, if this is my leaving group at beta carbon, we must have an electron withdrawing group. There on beta carbon, we must have an atom which is capable of donating a lone pair. Here in E1CB, on the beta carbon, we must have an electron withdrawing group. So when we are having electron withdrawing group, the leaving group, what happens is leaving group is not leaving first. Because the entire arrangement is such कि हमारा जो बेस है वो एब्स्ट्रैक्ट कर लेता है H plus पहले. So abstraction of proton takes place first so that you get a carb anion. So here carb anion intermediate is formed, which is very well taken care of because of the electron withdrawing group. And since you have an electron withdrawing group which takes care of this carb anion, what happens is you have a weak conjugate base. So what happens once this is gone, this comes here because carbon ion is being stabilized because of electron withdrawing group. This can come here and this can leave, and that's how you get the alkene. So this was E1CB. EI also is not something that we have done. EI में आप बहुत पूछा नहीं जाता है, but you must know what happens is हमारे पास internal leaving groups लगे होते हैं which are very good leaving groups, जिनका काम ही है बस छोड़कर जाना. वो आते ही जिंदगी में इसलिए ताकि वो चले जाएं. जैसे कि आपका एस्टर्स, ज़ैंथेट्स, अमीनो ऑक्साइड्स, ये सब लगे ही जीवन में इसलिए हुए हैं ताकि ये फटाफट चले जाए, और इंटरनली ही एक बेस की तरह काम कर रहे हैं कि आए हैं क्राइम मास्टर गोगो. आई डू नॉट नो इफ योर जनरेशन इज नोइंग क्राइम मास्टर गोगो और नॉट. डू यू नो हु इज क्राइम मास्टर गोगो? वी लव्ड हिम. वी मिलेनियल्स लव्ड क्राइम मास्टर गोगो. शक्ति कपूर. यप. What's his statement? आया हूं तो कुछ तो लेकर जाऊंगा. So, आया हूं तो कुछ तो लेके जाऊंगा, ये वाली बात है यहाँ के लीविंग ग्रुप्स के भी. जैसे कि एस्टर्स, ज़ैंथेट्स, अमीनो एसिड्स, ये आए हैं तो कुछ तो लेके जाएंगे. तो what they do is आते हैं और प्रोटॉन को लेके जाते हैं, राइट? So, मोय yeah, that's true. You guys only know moy moy. कोई बात नहीं. I will act like a bridge. You know, there's a reason why millennial teachers are resonating the most with the Gen Z generation is because we can understand what you know and we can also understand what you do not know. So yes, These are like Crime Master Go-Go, very famous. You must look classic movies. Classic movies are amazing. जिसमें he always keeps saying कि मैं आया हूँ तो कुछ तो लेके जाऊंगा. So यहाँ पे ये सारे जो leaving groups हैं, which are very good leaving group, they come and take hydrogens away. They are a part of the molecule, so you rarely encounter them, but you must know. Correct? So this is again simple. Next one is cyclization. Elimination यहाँ पे कैसे हो रहा है कि आपका सीधा का सीधा Woods reaction में जैसे कि आपने देखा कि सोडियम 2 ब्रोमीन निकाल लिया, एक साइक्लाइजेशन हो गया. और बाकी रिएक्शन विद मेटल्स क्या है? बहुत सारे रिएक्शन विद मेटल्स हैं. ग्रिग्नार्ड है, फ्रैंकलैंड है, वुड्स है. वुड्स हम अच्छे से कर चुके हैं. ग्रिग्नार्ड एक बारी देख लेते हैं और फ्रैंकलैंड देख लेते हैं. राइट? उल्मन भी है. विल ऑल्सो टॉक अबाउट उल्मन्स रिएक्शन. सो मेटल्स के साथ 4 रिएक्शन आप मेरे मुंह से सुन रहे हैं. ग्रिग्नार्ड, फ्रैंकलैंड, वुड्स, इनफैक्ट गिलमन एंड उल्मन. ये 5 रिएक्शंस काफी इंपॉर्टेंट है. लेट्स सी ग्रिग्नार्ड फर्स्ट. राइट? ग्रिग्नार्ड में do not forget this thing that what we take is RMgX. This magnesium is of course electropositive, so this R becomes electronegative, R minus. If you understand this thing that it is just the game of opposites, it is just opposite attracts. If you understand this thing, everything is going to be simple. Opposite attracts बोले तो RMgX. अगर मैं लेती हूँ RX के साथ, when I'm taking alkyl halide, you can see when halogen is attached to the carbon, then this carbon will be delta plus because halogen is delta minus. So अपने में बस ये opposite attract करना है, plus के साथ minus लगाना है. R, let's say this is R dash, so what you get is R dash. It is a step up reaction. Carbons are going to increase here, right? So this is Grignard reaction. Check this out. And since on the introduction of magnesium in Rx, अगर मैं RMgX देखूं, मैंने Rx के बीच में magnesium डाल दिया, उससे क्या हुआ है? Something which was delta plus has become delta minus. So this is umplong. Umplong matlab reversal of polarity. There is a reversal of polarity happening on the introduction of magnesium here, right? So this is one Grignard. Then you have Franklin reaction. Franklin में बच्चा पार्टी जो आपने Woods के साथ देखा था ना, याद है Woods reaction? RX, Na, RX. मैंने कैसे बोला था कि let the X face the sodium and take 2 moles of sodium such that you get 2 moles of NaX out, so that you get RR clubbed together. So इधर क्या use होता है? इधर instead of zinc sodium you just use zinc in Franklin. That's it. Right? Yeah, umplong is, I do not know what word, the origin, you can check and let me know. Umplong means reversal of polarity. I'm not sure of the origin, whether it's Latin or not. Just check and let me know also. Will be help for the entire class. So when we are talking about Franklin, this is clear. Then if we talk about Woods reaction, Woods तो हमें पता ही है यार. Woods में sodium लेते हैं हम, dry ether लेते हैं. We know the डब्बा method also, the box method. NaX निकल जाता है, step up reaction है, right? And what you get is alkane. So this is Woods, for example, let's say methyl chloride. Then what you get is CH3CH3, right? अगर मैं ले लूँ R2CuLi, right? It's German? Okay, great. So in organic, umplong, which is German, is for the inversion of the polarity, right? Great. So it's a German word. Thank you. I'll remember now. Okay. So CH3Cl plus Na in the presence of dry ether gives you CH3CH3 plus NaCl. So when you're taking R2CuLi, this is going to be called as Gilman's reagent, right? So with CuLi, when you have R2CuLi, this is called Gilman's reagent, and the reaction is absolutely similar. All that is out is your RR dash, like there's a coupling once again, and the method is called Corey-House synthesis. So Gilman is the man behind this particular reagent, only R2CuLi, alkyl group attached to copper and lithium, but the method is called Gilman, Corey-House synthesis, right? Man behind the reaction is somebody else, Corey-House. Okay? Let's now see a question before we move ahead. Look at this question and tell me. Which of the following, and clearly the language of the question is such that it's a multiple select question. Which of the following depicts the reason for the use of dry ether as solvent in Wood's reaction? I've done this deliberately. I've not talked about it again. I wanted to put it as a question only. Sodium does not react with dry ether. Sodium reacts with polar aprotic solvent. Sodium reacts with polar protic solvent. Sodium reacts vigorously with dry ether. So, it is an MSQ, keep in mind, okay? More than one answer can be correct. Keep that in mind before answering. Okay, so let me tell you, I know A and C looks very luring, okay? A and C looks very perfect. Ki sodium does not react with dry ether, certainly. So, agar sodium does not react with dry ether, then D cannot be your answer, which says sodium reacts vigorously with dry ether. So, either A can be correct or D can be correct. So, if it is A, which we know A is correct, D cannot be correct, so D is ruled out. But why only dry ether? Have you ever thought about it? I have never mentioned DMSO there. I have never mentioned DMF there. I have not mentioned any other solvent other than dry ether. Have you ever heard me saying acetone there? Yeah, I know while talking about Finkelstein, when we were talking about NAI, we were talking about acetone, but have we ever talked about any other solvent other than dry ether when we are talking about Wood's reaction? Ever thought about it? Simple thing. I know, very simple. Wood's reaction, our favorite. Who doesn't know about Wood's reaction? Everybody. With subtle nuances, and you will be in soup. The moment I say which of the following is incorrect, and let's say I change option D and to all of these or none of these, you will be in soup. Mind you, it reacts with polar protic solvents also. It is just with dry ether that things are quite clear. Dry ether ke saath it is best suited because it does not react with dry ether, does not react. And you also know that it keeps the conditions dry. And when we talk about things being dry, we mean they are free from moisture, which we do not want. So, no DMSO, no DMF, no acetone, nothing, only dry ether. So that means sodium has an ability to react because of the dipole, ion dipole interactions maybe, right? There is a possibility of ion dipole interaction that can make things worst. With ether, it is best. Hence, specifically, it's dry ether which is mentioned. Okay? Now let's talk about the chemical properties. So I hope this is clear that A, B and C, all three becomes the answer to this question. Okay, none of you gave it right. But this time I'm not going to fall because I knew it you will not give it right. So yeah, I anticipated. So whenever I have anticipated something, I am in good spirit because I know that some takeaway has reached you. कुछ तो आपने सीखा ही होगा, कुछ नहीं हुआ तो तजुर्बा हुआ। बट जब कुछ चीज पढ़ाई हुई है, बहुत अच्छे से पढ़ाई हुई है, तभी भी आप गलत देते हो, देयर आर चांसेस दैट आई माइट फॉल ऑन द फ्लोर एंड इट माइट हिट मी हार्ड कि भाई इतना ज्यादा अच्छे से पढ़ाते हुए भी आप गलत कर रहे हो। ये नहीं करना है। जैसे कि हम आगे वाली जो चीजें बहुत बहुत अच्छे से कर चुके हैं, सो आई एम श्योर द क्वेश्चंस आर गोइंग टू बी इजी पीजी फॉर यू. We have done already for haloarenes electrophilic substitution quite well. If you remember, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, nitration and halogenation. All these are electrophilic substitution where 3 steps were happening. Number 1, formation of electrophile. Number 2, we had this thing, loss of aromaticity. And third one was the regain of aromaticity. Tanish is asking, ma'am, what if we take tertiary butyl chloride? Then will the Woods reaction proceed? So Woods reaction, Tanish, is like I mentioned SN2 mechanism. And SN2 mechanism agar follow kar raha hai, so we know it is quite hard for it to actually go by SN2 mechanism because of the transition state that will be formed, right? So it is tough, but nonetheless, you will get some amount, not a very high yield, but possible. Okay? Ma'am, strategy for organic for class 12, for last 12 days, please. I'm certainly planning a series like that, Mahendra. Don't worry about that. I'll keep you posted. अभी तक का जो जो है प्लान वो मैंने बता दिया, जो 100% प्लान है. I do not want to commit anything which I'm not able to fulfill. I will always speak something which I will be able to preach. Which I will be able to practice. So, I'll not just preach, I will make sure whatever I say, I practice that. So, I'll keep you posted on that. Let me see how can I manage my schedule. So, electrophilic substitution is all done. Nucleophilic substitution also is something that we have done well. And reaction with metal also we have seen. So, reaction with metal, with alkyl halide we just saw. But with aryl halide, we have to see once again. Grignard reagent is all clear, I believe. कोई दिक्कत नहीं होना चाहिए. बस अगर मैं mgx ले रही हूँ इस तरीके से with rx, so we know delta plus, this is delta minus. So there can be just directly coupling here also, right? Grignard reagent is as simple as what we have done in alkyl halide, nothing different. Fittig reaction, if you are following Aakash Baiju's JEE channel, this is what I posted on the channel also. How many of you saw it? The Fittig reaction, you saw it? This meme? क्या बेचारे एक ने मेहनत करी, वुड्स ने इतना मेहनत करी, तकल्लुफ उठाया, देखा एक ऐसा रिएक्शन जहां पे एल्केन बनाया इस तरीके से कि सोडियम, such a, like I told you, he came up with all the permutations and combinations of which best solvent goes by. You know that sodium is very reactive, so he made sure कि एक ऐसा solvent use करे जिससे inert atmosphere भी maintain रहे, dry conditions भी maintain रहे और इस तरीके का coupling भी हो जाए. So there was coupling that was happening, but क्या किया Fittig ने कहा, oh, you're doing it with alkyl halide. I want a named reaction on my name also. So let me have a named reaction on my name by taking benzene instead of alkyl, and here he had it. He had the reaction on his name. In a way it's different, so it's okay, but yeah, the man behind was certainly Woods. And वैसा ही copy कर दिया Fittig ने, एकदम देखा and अपने ऊपर named reaction रख लिया. Good for him. And we know that if we talk about Woods Fittig, it's a conglomeration of the two. Woods का alkyl halide, Fittig का aryl halide, दोनों को भी हम एक दूसरे से couple कर सकते हैं. Again, the conditions are same, sodium, dry ether, but what happens? There is aryl halide as well as alkyl halide both being used, and what you're getting is a chain, on a benzene. आपके पास एक alicyclic system on a cyclic system आ रहा है, right? चलो, हाँ, बिल्कुल सही श्लोक. फेलिंग और बेंडिक की भी कहानी बिल्कुल सेम है. मेहनत करे एक, फल ले जाए दूसरा. I mean, this happens a lot. Between friends also this happen. And then you're like, ठीक है, ओके कई बार होता है ना, मार्क्स दूसरे के भी आ जाते हैं उतने जितने आपके आए, मेहनत आपने करी है और एग्जाम में आपने बताया पूरा का पूरा, मार्क्स सेम ले आया, दुख तो होता है, राइट? उस वक्त तो बेनिवोलेंट हो जाते हैं, बट दुख तो होता है एट द एंड ऑफ द डे. वी नो दैट वी आर ह्यूमंस एट द एंड ऑफ द डे, राइट? उल्मन, तभी जरूरी है अच्छी ट्राइब ढूंढना, बहुत जरूरी है. अभी जिस संगति में आप लोग हैं वो बहुत जरूरी है. दैट विल हेल्प यू, इट विल मेक यू और ब्रेक यू. द कंपनी दैट यू आर इन, द फ्रेंड्स दैट यू आर सराउंडेड बाय. I don't mean to say your happening friends are not the friends that you shouldn't keep. You keep your happening friends with you. Nobody is asking them to throw them out of your life. But if they are your friends, they will stay with you even after 6 months. So abhi unke chakkar mein apni happening life bana rahe ho at the cost of studies, then that will not take you far, for sure. ठीक है, चलो. अब उल्मन रिएक्शन क्या है? उल्मन भी बहुत सिमिलर रिएक्शन है जैसे कि फिटिक रिएक्शन देखा था. फिटिक रिएक्शन में आपने, इफ यू रिमेंबर, व्हाट वी टुक वाज aryl halides with sodium, right, with 2 moles of sodium. So this was all going away and we got a biphenyl system. Here we take copper in zero oxidation state. So when we are taking copper in the zero oxidation state, copper iodide gets removed out and we get this, coupling reaction, diphenyl or biphenyl system. This is what we get, right? Is it a good reaction? Not very good, because you require very harsh conditions, high temperature conditions, and you need to maintain a lot of other conditions as well. So in terms of the feasibility, not a very feasible reaction. So let's see now how much you've understood with questions. The Wurtz-Fittig reaction involves Wurtz-Fittig reaction involves 2 molecules of aryl halide, 2 molecules of alkyl halide, 1 molecule each of aryl halide and alkyl halide. Direct question from what we just did. C becomes the answer. Easy one. Next question. I'm sure this was easy. Next question. The major product in the following reaction is, you have a phenyl chloride with Br2. You're taking anhydrous FeBr3. You need to tell me the product. Major product. You know the ritual. I will keep enhancing the level. बहुत basic से start करके level बढ़ता है. So be very prepped up. Okay. So Mahendra Singh Dhoni is saying B, Pratham is saying B, Bimlesh is saying B, Ajay Pratap is saying B, Aditya Verma is saying C. Okay. Metabromochlorobenzene. C. Tanish is saying B. Cl is ortho para directing group. प्रथम ने आंसर दे दिया, but फिर भी उनमें से भी मेजर बताना है. Aditya is still saying C for the 4th time now. Or if I count पहली बार जो CCC है तो 1 2 3 4 5 6th time now. So is it clear that this is nothing but halogenation reaction, electrophilic substitution reaction, and when we are talking about electrophilic substitution reaction, then the bromine gets added either at ortho or para. You know bromine is huge. Chlorine is also huge. Both have lone pairs, so they're going to repel each other. So ortho one is not going to be major. Para is going to be major. So para bromochlorobenzene will be the answer. So Verma Sahab, C nahi hoga. Rest, all of you were absolutely right. B becomes the answer to this question. Easy one. Let's enhance the level a bit now with the next question. The correct order of increasing reactivity of CX towards nucleophile in the following compound is. So you have an aryl halide. Second compound is aryl halide with the 2 nitro groups. Third compound is a 3-degree alkyl halide. Fourth compound is a 2-degree alkyl halide. Order बताना है. Okay. Mahendra Singh is saying C. Shlok is saying D. Tanish is saying D. Ajay Pratap is saying C. Huh. Told you. This can be a twister. Nidhi is saying C. Okay, तो मतलब A और B 50-50 आपके सामने हो चुका है. There is no confusion in A and B for sure. B या तो C बोल रहे हैं या D बोल रहे हैं, तो this is what we have to think of कि क्या आंसर हो सकता है. क्या मैं आपको ऑलरेडी बता चुकी हूँ कि aryl halide में halogen is involved in resonance and there is a partial double bond character developing, because of which this was an unactivated system towards a nucleophilic substitution. Not just that, we saw why SN1 cannot happen because there is no possibility of aryl carbocation being formed. Neither SN2 was possible because there was no possibility of attack from the back side because of such electron dense system. No mechanism was possible if you remember. ठीक है, और ये टूटना भी नहीं चाह रहा था, तो नाइट्रो से थोड़ा सा बेटर हो रहा था मामला, बट इट वाज बिकमिंग एक्टिवेटेड टुवर्ड्स SNAR. बट डोंट फॉरगेट दैट न्यूक्लियोफाइल कब लगना चाहेगा? न्यूक्लियोफाइल तब लगना चाहेगा अगर कार्बोकेटाइन है. अगर 3 डिग्री कार्बोकेटाइन है तो बहुत अच्छे से न्यूक्लियोफाइल आएगा और लगेगा ना वाया SN1. Here also when we have a 2 degree alkyl halide, of course third one is going to be better than the fourth one for sure, but again fourth wale mein bhi carbocation is still stable and nucleophile will come and want to attach, correct? In first and second it doesn't want to attach. So aliphatic systems are comparatively more reactive towards nucleophilic substitution than aromatic aryl halide. बट एरोमेटिक अराइल हैलाइड को रिएक्टिव करने के लिए हमको इलेक्ट्रॉन विड्रॉइंग ग्रुप का सहारा लेना पड़ रहा था, याद रखिए. सो व्हेन वी आर टॉकिंग अबाउट दिस 2 डिग्री अल्काइल हैलाइड, हु इज विनिंग? थर्ड इज विनिंग. सो थर्ड सबसे ज्यादा, फिर फोर्थ, एंड आउट ऑफ सेकेंड एंड फर्स्ट, सेकेंड बिकॉज ऑफ द इलेक्ट्रॉन विड्रॉइंग ग्रुप्स एंड देन फर्स्ट. सो थर्ड, फोर्थ, सेकेंड एंड फर्स्ट, डी बिकम्स द आंसर टू दिस क्वेश्चन. क्लियर? तो जितने भी बच्चों ने सी बोला है, याद रखिए क्यों हम बोल रहे थे अराइल हैलाइड अनएक्टिवेटेड है, और अगर इलेक्ट्रॉन डोनेटिंग ग्रुप लगाओ तो डीएक्टिवेटेड ही है, वो होना ही नहीं चाहेगा, न्यूक्लियोफिलिक एरोमेटिक सब्स्टिट्यूशन दिखाना ही नहीं चाहेगा. नाइट्रो ग्रुप है तो कंडीशंस एक्सट्रीम चाहिए थे. इफ यू रिमेंबर, जितना जितना नाइट्रो लगता जा रहा था, कंडीशंस एक्सट्रीम जितने थे उससे कम 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 एक्सट्रीम हुए जा रहे थे. नॉनदलेस मतलब चाहता नहीं है न्यूक्लियोफाइल लगना इस तरीके के सिस्टम पर. लग इसलिए रहा है क्योंकि नाइट्रो आ गए हैं. सो दिस डी बिकम्स द आंसर. ओके, नेक्स्ट क्वेश्चन. इन द फॉलोइंग रिएक्शन द प्रोडक्ट X इज, सो यू हैव C6H5CH2Br benzyl bromide. You're taking Mg ether H3O plus. अग्रिमा, अरुष, आई एम सो सॉरी, आपको पिछला सेशन देखना पड़ेगा. आई हैव डन SNAR ब्यूटिफुली इन द प्रीवियस सेशन. द टाइटल नेम वाज अल्कोहल, फिनॉल्स एंड ईथर, बट देयर वी हैव डन SNAR E1 एंड E2. यू कैन चेक दैट. एंड वी हैव डन इट इन डिटेल, सो शॉर्ट में करने का फायदा नहीं है. Okay, so I'm sure this is clear that C6H5 CH2 MgBr बन जाएगा. ये डेल्टा प्लस, यहाँ पे डेल्टा माइनस. अपन को बस ऑपोजिट अट्रैक्ट करना है. केमिस्ट्री में ऑपोजिट अट्रैक्ट. सो H3O प्लस का मतलब है हमारे पास H प्लस है. सो H प्लस डेल्टा माइनस, यू जस्ट कंबाइन देम, यू गेट टोलुइन. हाँ, अपने फर्स्ट अटेम्प्ट के बाद सेकेंड अटेम्प्ट के लिए जरूर प्रैक्टिस करिए, बट नॉट ऑल द क्वेश्चंस आर रिक्वायर्ड कान्हा फ्रॉम MS चौहान. बहुत बड़ा वही है, फिर आग का दरिया है और डूब कर जाना है. अगर आग का दरिया है और डूब कर जाने का मन है तो बिल्कुल अटेम्प्ट करिए, कोई मना नहीं कर रहा है. शौक है आपके, सबके अपने शौक होते हैं, राइट. नेक्स्ट वन, 2-bromo pentane is heated with potassium ethoxide in ethanol. The major product obtained is 2-bromo pentane. Okay, is heated with potassium ethoxide in ethanol. Okay, so this is clear. When we are talking about the elimination, so this must be clear that elimination हम कर रहे हैं. We are taking a strong base, and since we are taking a strong base, we know that there will be elimination, and the possibility of major product reaction can be, more acceptable and more suitable in the E1 mechanism. And you will get a trans as a major product. So trans 2-pentene becomes a major product, right? ठीक है. So काना, मैंने आपको जैसे बताया previous year questions are a must, and there is a huge number of previous year questions thanks to so many shift that happens, है ना. तो previous year question ही मैं recommend कर रही हूँ. इस वक्त MS चौहान मैं recommend नहीं कर रही हूँ. Anybody who asks me, until and unless you are in class 11th. Okay. Which chloro derivative of benzene among the following would undergo hydrolysis most easily with aqueous sodium hydroxide to furnish the corresponding hydroxy derivative? Easy question. So, Mahendra Singh Dhoni A, Pratham A, Saurabh A, Ajay Pratap A, Kazim A, Ritu Vyas A, all of you are saying A. A has to be the right answer, no doubts about it. Very, very clear it is that A becomes the right answer. Cool. Now, I'm sure this has given you an insight of the previous year questions also, as well as haloalkanes and haloarenes is well embedded now in your brain. Do revise it. Next session is going to be about alcohol phenols on Friday, right? और मेंटी का मैं आपको अपडेट देती हूँ in Bhumika ma'am's class. The topic that we're going to select, topic is always going to be now whatever we have done so far. So that is going to be our topic. Right, and let's meet tomorrow also if possible, but confirmation Bhumika ma'am will give you in her session. All right. Resolution जो लिया है, जो भी resolution लिया है, नहीं लिया है तो बहुत अच्छी बात है, you're already resolved, that means. But if you've taken any resolution, try abiding it, because the moment you leave it, you don't feel, there's no vigor of carrying it forward. And I really hope this year becomes a very fruitful year to all of you. And let's just try one thing, no matter what, for everybody. Let our present self be better than our past self. And with this is me, Nitika, signing off. Take a very good care of yourself. Bye-bye.